Okay, today we are going to learn about concept behind solving the points problem. Okay, so we know how to solve the points problem. So there is a concept here. So basically it involves three basic concepts. So based on these three basic concepts, we are going to solve the points problem. Okay, well, now we'll see what are those basic concepts behind solving the problems. So we can take concepts for solving points problem. So herein there are three concepts or conditions by which we can solve the points problem. So the problem is very easy. So first concept here is identifying the quadrant. So from the question we need to identify which quadrant it is. Okay, if I say an example, say if a point is lying 30 mm above HP and 20 mm in front of AP, means it is in first quadrant. Okay, like that, first thing is we need to identify which quadrant. Either it is an first quadrant or second or third quadrant. We need to identify. So the first thing is we need to identify the quadrant. Similarly, you can say that if a point P is lying 30 mm behind of EP and 20 mm below of HP, that means in third quadrant. So that is the first concept. That means we need to identify the point is lying in which quadrant. Okay. Now, second concept is writing the conventions for the identified quadrant. Say we have been identified it is an first quadrant. So what is that? The convention for the first quadrant means we need to write it in by means of xy with the VP HP. Okay. So this is the convention for first quadrant. Say we need to write it in terms of orthographic views. Okay. That's what writing the conventions for the identified quadrant. Say we have been identified, say the point A, say 30 mm above HP, 20 mm in front of EP, it lies in first quadrant. Say if it is lies in first quadrant means with respect to first quadrant, so what is the convention for it? So that is our second concept. Okay, that is our second concept. So now it comes with the third concept, that is nothing but visualization. So visualization is very important concept. So now we will discuss deeply. So how a visualization will be. Okay. So now you understood, right? There are three basic concepts for solving the points problem. One is identifying the quadrant. That means we need to identify the point. Either it is lying in first quadrant, second, third or fourth. Next, with respect to the quadrant, we need to write down the conventions for it. Okay. That is writing in terms of HP, VP with respect to the XY line. Now the third concept, it is nothing but visualization. Visualization means we will be seeing how we are looking the thing. Okay, how we are looking the thing. So that's what the visualization. So how we are looking the things from it. So we can able to define what is exactly the visualization is. Okay. So now we see what is visualization is. So in the visualization, this is a very important concept. So in the visualization, I will take bit by bit one of the each of the concept. So first take I define now a point is lying above HP or below HP means it is an front view. So what is this? If a point is lying above HP or below HP means it is an front view, means it is based on the visualization. Say if I take this one, so this is our horizontal plane, correct? This is our horizontal plane. Say if any point, say consider this is our pen. If it is lying above HP or below HP means, so this point which is having certain distance from this horizontal plane, okay, say some 50 mm above HP or 30 mm below HP, this distance plus weave can be projected on the vertical plane, correct? So you can say that if any point, if it is lying above HP or below HP means it is an front view, because the distance from that particular HP plane, if it is above HP or it is below HP, it can be seen only from the front view. That's what visualization, how we are looking the things, okay. If the point is lying above HP or below HP means it is an front view, okay, because the point how much farther from this HP plane, say 50 mm, 60 mm above HP, can be seen from the front view. Similarly, a point is below HP, how much below of it, say 100 mm, 50 mm, 20 mm, how much it is farther from it, it can be seen only from the front view. That's why if any point lying above HP or below HP means it is an front view, okay. So understood. So now similarly we can write it for the second one, okay. If any point, okay, any point is lying in front of VP and behind of VP means it's an top view. So how it is? So second concept, say if any point, say this is our front, this is our vertical plane, correct? Vertical plane. If any point it is, say if it is lying in front of VP or behind of VP means this how much it is front or how much it is closer to it, it can be seen only from the top view, correct? Only seen from the top view. Say if any point it is lying in front of VP or behind of VP, it can only be seen from the top view. How much it is for, say 40 mm in front of VP or 50 mm behind of VP, it can be seen only from the top view. That's why it is an top view. You can see that if any point it is lying in front of VP or behind of VP means it is an top view, okay. So that's how we are going to visualize, okay. If any point, here point P, say it is 50 mm in front of VP or 40 mm behind of VP, it can be seen only from the front view, okay. So now we all understood, right? This is how we can able to visualize, okay. Say I am going to repeat it again. If any point is lying above HP or below HP means it is an front view, because we are able to see the things from the front view. Similarly, if any point is lying in front of VP or behind of VP means it's an top view, because we can able to see the distance, how much it is nearer or farther from this vertical plane can be seen from the top view, okay. Guys, you understood? Today we are going to learn about basic concepts related to visualization. Okay, so in this we will learn bit by bit. If a point lies above HP and on VP. Okay, so if a point lies above HP and on VP, you will be hearing this word on VP for the first time. So be remember, on HP means it is top view, okay. So above HP means we know that it is front view. So we need to find out what is front view, where the front view it is lying, okay. So we know that in quadrant system there are 4 quadrants, okay. So this is our first quadrant, second quadrant, third quadrant, fourth quadrant, okay. So you can see that if a point lies above HP and on HP, we already got the top view. Now we have to look for the front view. So above HP means, this is our HP plane, correct. HP plane is our vertical plane. So above HP means our point, the front view can lie in either in first quadrant or second quadrant. So that's what. So the front view, can write front view can lie in first and second quadrant. Okay, so the point will be lying, that is the point will be lying in first and second quadrant. Okay, now we'll see the second concept. If a point if a point lies in front of VP and on HP. So we know that on HP means it is front view. Okay, so on HP means front view. We have to see further in front of VP means, so in front of VP means it is top view. So where the top view will be lying. So in front of VP means this is our vertical plane. In front of VP means there are two chances. Our front view can lie in first and fourth quadrant. That is, we can write, so top view can lie in first and fourth quadrant. So that is, point will be lying in first and fourth quadrant. Similarly, okay, if a point lies behind of VP and on HP. On HP means it is front view. So behind of VP means it is top view. So we have four quadrants. Vertical plane. This is horizontal plane. This is our first quadrant, second quadrant, third quadrant, and fourth quadrant. So top view behind of VP means there are two chances. The point may, the front view may, sorry, the top may lie in second and third quadrant. So I can write top view may lie in second and third quadrant. So that is, point will be lying in second and third quadrant. Okay, similarly, if a point lies below of HP and on VP. So and on VP means this is our top view. So below of HP means it is front view. Okay, so below of HP means we have to see it. So below of HP means two chances. The point may lie in third and fourth quadrant, that is front view. So we can write front view may lie in third and fourth quadrant. It is, point will be lying in third and fourth quadrant. So the point may be lying in third and fourth quadrant. Say if a point lies below HP and on VP means below HP means two chances, third and fourth quadrant. So the front may lie in third and fourth. That is, finally the point will be lying in third and fourth quadrant. Okay. Today we are going to discuss problem of points on side views. Okay. So in this problem, so we will be dealing with the side views here. So we will go with the question. A point P is lying. P is 30 mm in front of VP, 40 mm above HP, and 50 mm from RPP. Okay. So in this problem, so as we have know, so it involves three concepts. First, to identify the quadrant. So in front of VP, above HP means it is our first quadrant. So for the first quadrant, we know the notations. So VP, HP, XY. That means first we are going to draw this first quadrant, top view and front view. Okay. Okay. So we know that 30 mm in front of VP means it is in front of VP means it is top view. So top view it is drawn in the HP plane. So 30 means 3 boxes, and you put a point. So that is here the top view. Similarly, 40 mm above HP. So 40 mm above HP means it is our front view. It is 4 boxes. It is P dash. So now we'll show with the dimensions. This is 40 mm and this is 30 mm. Now you can see this 50 mm from RPP. This is what the side view. So where it is exactly means in the quadrant. You can see this. So this is our HP plane and this is vertical plane and this is our RPP, right profile plane. So this right profile plane, it is adjacent to the vertical plane. Okay. So in this problem he is mentioning that a point P is 30 mm in front of VP and 40 mm above HP and 50 mm from the RPP. So this it will be there adjacent to the vertical plane. Okay, when it is drawn in the orthographic, so it will be like this. Okay, so front view, top view, this front view connected with the side view. Okay, so that means for this RPP we will be drawing another x1 y1 line at a distance of 50 mm. Okay, now to draw this side view with the top view, we will be using 45-degree angle line. Okay, so you just follow the procedure. Okay, now from this projection point we have to consider a distance of 50, that is 5 boxes. Keeping this distance of 5 boxes, here we are going to draw x1 y1 line because it is 50 mm from RPP. So this is x1 y1 RPP, right profile plane. Okay, now we know that so side view will be there adjacent to this front view. So we draw a straight line. After this we know that we have to draw an 45-degree angle line here. Okay, in order to connect the top view with the side view. So that is 0, 10, 20, 30, 40, 45. So mark a point, then draw a straight line. This is your angle line, that is 45-degree angle line. Now from this top view, so you will be drawing a straight line until it touches the 45-degree line. Then we project upward. Okay, so where these two lines are intersecting, so this point is our side view. Okay, this is what the say, and we can show the direction of the projection line. Okay, so this is what the side view. Welcome to Engineering Visualization channel. Okay, today we are going to see problems on points problem. Okay, so as we have discussing the problems on points, okay, so it is one of the different type problem. You can see in this problem they have not given any kind of dimensions. Instead of it, so using the concept we have to solve the problem. Okay, you can see the question here. Draw and state the quadrants in which the following points are located. Assume any distance. That means the distance you can take any of it. Okay, you have to identify which quadrant each of these points are locating, and then you have to write it by assuming any distance. Okay, so you can see front view below xy line and top view above xy line. So it is third quadrant, right? So I'll write here only. It is third quadrant. Similarly, front view and top views are below xy line. So this is fourth quadrant. Okay, front view and top views are above xy line. It is second quadrant. Okay, front view above xy line and top view below the xy line means, so it is your first quadrant. Okay, so it is easy to write. So first I am going to draw one xy line here. Okay, so here they have not mentioned to take exact distance, so conveniently you can take any of the distance. Okay, first I am mentioning this, the point here. Okay, front view below xy line and top view above xy line. So front view below xy line means this, I'm taking convenient distance and I'll put a point. So this is a dash. Similarly, this is a top view above xy line. Okay, this is your third quadrant. In the same way, leaving convenient distance, front and top views are below xy line. So I'll be mentioning here. Okay, both on the same line. I'll mention B dash. Okay. Next, front and top views are above xy line. So above xy line means I'll give one as 30 and another will be on 40. So here C and C dash. Next, fourth line, that is a point number D, front view above xy line, front view. So here I'll mention front view. This is D dash and top view below the xy line. So here it is. So here we have assumed any of the distances. You can assume it. It is given in the question. Okay, so that completes the problem. Okay, you can mention, if you want to mention, you can mention here A is in third quadrant. Okay, and B is in fourth quadrant. Okay, similarly C is in second quadrant and D is in first quadrant. Okay, so that completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited. Thank you all. Thank you for watching the video. Okay, today we are going to discuss another problem on LPP, that is a side view problem. So the first problem we have done with the right profile plane. So now we are going to do the problem with respect to the left profile plane. Okay, so we know the procedure. First, to identify the point is lying in which quadrant. The point is 40 mm. The point, you can say point B here. Okay, point capital B is 40 mm behind of VP and 20 mm above HP. So it is in second quadrant, behind of VP and above HP. So for the second quadrant, so we have vertical plane, horizontal plane lying above the XY line. Okay. So XY, another both vertical plane and horizontal plane lying above the XY line. Now 40 mm behind of VP. So behind of VP means it is top view. Okay, behind of VP means it is top view. So I'll be drawing here 40 mm means 4 box. So it is small b, top view. Now 20 mm above HP. So above HP means it is our front view. So the same collinear line we can mention 20 means 2 boxes. It is B dash. So now we can show the dimension here. So it is 20. So it is 40. So now we have done with the both the top view and front view. Now we have to do the side view. So you can see this from 30 mm front, behind are from LPB. So that means from this projection we have to consider 3 boxes here. Okay, 3 boxes here, and we will be drawing a dimension line. Okay, that is 30. So here exactly leaving a 3 boxes, that is 30 mm, we will be drawing a projection profile plane, that is x1, y1, LPB, that is a left profile plane. Okay, so now we know the procedure. Where there will be a top view, we have to draw an angle line here. So we will be doing the same procedure. So intersection of these two lines here exactly, so we will be marking for 45 degree. Okay, so it is 45 degree. Now from this point, so we have to draw a straight line, and we know that with respect to the front view we have the side view, so that's why I'm drawing a straight horizontal line adjacent to it. Okay, so from the intersection of this point, okay, from the top view intersection to the 45 degree line, so we have to draw downward. Okay, so here at the intersection of these two lines, so we get an side view B double dash. Okay, so B double dash, so this is what the direction of the projection line. Okay, now in this question they have mentioned name the side view, which view it is. So it is a second quadrant, in second and fourth quadrant. So it comes to the, you know, that second and third quadrant comes under third angle projection. Okay, so it comes under third angle projection. So in third angle projection, what happens with respect to the LPP, we have left side view. Okay, with respect to the RPP, we have right side view. So this is left side view. So this is, we can write here, left side view. Okay, so today we are going to learn on a single point how two or more views exist in a points problem. So we are going to discuss. So you can see the question. A point 30 mm above xy line is the front view of 2 points. You can see in this question, a point 30 mm above xy line is the front view of 2 points A and B. Okay, for the 2 points A and B is mentioning the front view, that is A dash and B dash, it will be lying above the xy line at a distance of 30 mm. Okay, so that's what it is directly mentioning. So we will be proceeding with the question. Okay, how it's mentioning. So this is another type of problem. Okay, so in this problem he is mentioning 30 mm above xy line, as we will be proceeding with the question. So 30 mm above xy line, so we drawn 30 and we have put a point. So this point 30 mm above xy line, it is indicating front view of 2 points A dash and B dash. So we'll be showing the dimensions. Okay, so that is our front view. Okay, the single point which is indicating two views, and it is lying at a distance of 30 mm above xy line. We have done it. Now we have to see, this is what the front views. Now we have to see for the top view. The top view of A is 40 mm behind of VP. So you can see the top view of A, top view of A is 40 mm behind of VP. So behind of VP means, there are two chances. So this is behind of VP. So either the top view can lie in second quadrant or it is in third quadrant. Okay, so we see in the third quadrant, so HP VP, so the top view is lying above the XY line, and third quadrant also HP, it is lying above the XY line. You can see in this, the point A is 40 mm behind of VP. Behind of VP means two chances, either it is in second quadrant or third quadrant. In second quadrant also HP will be lying above the XY line, and in third quadrant also HP will be lying above the XY line. We know that the top view will be drawn in the HP planes. So that is, when you collinearly we have to draw the top view. Okay, already we have drawn 30. So we will be extending by 10 mm. Okay. So put a point, that is our top view. So 40. Okay. Now similarly, the top view of B is 45 mm in front of VP. So the top view of B is 45 mm in front of VP. So in front of VP means we know that there are two chances, either in first quadrant or in fourth quadrant. Okay, so in first quadrant, so where the top view is, so in fourth quadrant, so we know that HP VP lying below. So you can see this in the first and fourth quadrant, in both the cases the top view is lying below the XY line. So that means we will be drawing below the XY line 45 means 4.5 box. 1 2 3 4 4.5 box. Here you have to draw till here. So put a point, and this is your top view. Mention with the dimension line. Okay, so this is what the problem of on a single point, two or more views. Okay, today we are going to learn about shortest distance problem in points. Okay, so they will be giving the shortest distance in this problem. So nothing but a arc distance we have to consider here. So in this type of problem they will be mentioning about only one view. Okay, using the shortest distance we have to construct all the three views. Okay, now we proceed to the question. You can see this is shortest distance problem. A point A is 20 mm above HP. Above HP means we know that it is front view, so we get it about the one view, and it is in the first quadrant. That means he is telling that we have to consider the first quadrant, that is VP above XY line and HP below the XY line. And then after that he is mentioning, and its shortest distance from the XY line is 40 mm. That means arc distance of 40 mm you have to consider to construct it, and then draw the projections, determine its distance from VP. Okay, so you all understood, right? In this problem they are mentioning only one view, that is front view, and then they have given the hint that we have to consider the first quadrant, and then they have given the shortest distance. So shortest distance means arc distance. So arc distance, that means we have to consider a compass here. Okay, so we know that it is in first quadrant here. So VP above the XY line, HP will be below the XY line. So we will proceed with the question now. Y. So you can see this 20 mm above HP. So 20 mm above HP means, so it is in first quadrant. So HP VP we have written. Above HP means it is our front view. So that means I'll be drawing the front view first. So 20 mm is 2 box. Put a point, that is A dash. Okay, so 20 mm it is done. Now you see that, so it is in first quadrant, we know its shortest distance from the xy line is 40. That means shortest distance from the xy line is 40 means we have to consider here, so x1 y1 line, okay, means from that intersection of that x1 y1 profile line we have to draw an arc here. Okay, so for that we have to consider a scale here, and we have to consider 40 mm. So take compass and measure 40 mm means 4 centimeter. So from this point to here take exactly 40 mm. Okay, so from this intersection point of this, okay, from this intersection point of this you draw an arc. Okay, after drawing the arc you mention the radius, okay, R40. So mention it R40. So after this what we do, after drawing an arc, so from this front view we will be drawing a straight horizontal line, okay, as it is intersecting this point arc. So this point is nothing but our side view, that is A double dash. Okay, now we have to draw a top view. So for that what we do, so here in this case we will be drawing an 45-degree angle line. Okay, all the three views you have to draw it. So for that we'll be drawing 45-degree angle line, 40 45. So we can mark a point here. Okay, so this is our 45-degree angle line. Okay, now we can draw from this side view a vertical line until it touches the 45-degree angle line, and then draw, and from this point you draw an straight horizontal line. Okay, you know that the front view and top view are there in a straight collinear line. So we'll be drawing a straight vertical line here. Okay, so where these two lines are intersecting, this point is our top view. Now we can measure the dimension because it is mentioned in the question. You can see that, draw the projection, determine its distance from VP. So we need to measure. So it is around 39 mm. Okay, so it is around 39 mm. So you can mention 39 mm. So this is what our shortest distance problem. Let us see different type of problems in points. Okay. Now you see 2 points RS are on HP. So R on HP means we know that these are front views. Okay, so front views are on HP means these front views will be there on the XY line. Okay, so 2 points R and S are on HP means, so these are front views. So these front views will be lying on the XY line. Now we see the point R is 35 mm in front of VP. Okay, so in front of VP, so R is 35 mm in front of VP. So in front of VP means two chances, first quadrant and fourth quadrant. So in first quadrant, so in front of VP means we know that this is top view. So VP HP below the XY line. So here XY HP VP. So in both the cases, so this R top V, it is lying below the XY line. Okay, so now we will draw the first the top V. Y. So first I'm going to draw this top V or 35 mm below the XY line. 35 means here 3.5 bucks. 1, 2, 3, 3.5 bucks. So till here. Okay. So the point, this is small r. Okay. So small r top V. This is 35. So we know that 2 points R and S are on HP, means these are front views. We know that top and front view it is collinearly joined. We know that front view of R, it is there on the XY line. So that is R dash. Okay, R dash. Now we will proceed. While S, you can see that while S is 50 mm behind of VP. So now see for the S. Sorry. Now we will see for the S. S is 50 mm behind of VP. So behind of VP means two chances. There are second and third quadrant. So second quadrant. So what happens in the second quadrant? Behind of VP means these are top view. So VP, HP. So above XY line in the second quadrant, and in the third quadrant also. So we get HP and VP. So in both the cases you can see that the top view, okay, the top view of S, it is lying above the XY line. Okay, so we know that we can draw, we have to draw here above the XY line, but before that you see the line joining their top views makes an angle of 50 degree with XY. Okay, line joining with their top views makes an 50 degree with XY. So this is our top view from this. So the top view, yes, will be exist somewhere here. We have to draw and 45 degree and 40 degree angle line. Okay. So mark for 40. So from this point, just draw a straight line. Okay, just draw a straight line. Okay, we know that we know that the top view of S, that is top view is lying 50 mm behind of VP. So behind of VP means it is lying above the XY line. So for that purpose, what we do, we will be drawing an 50 mm 1 2 3 4 5 50 mm line here. Okay, 50 mm line. Okay, 50 mm horizontal line, 1 2 3 4 5. So 50 mm horizontal line. So that is nothing but locus of S. That is nothing but locus of S. Now we see that, so where this intersection of this 45 degree angle line with respect to this 50 mm, so we have drawn this. Okay, 50. So where these two are intersecting, this point is our the top view of S. Okay, top view of S. So collinearly, if you drawing downward, so this point is nothing but the front view of S dash. Okay, now we have to find out the distance here from this point to here. So horizontally find out. So the distance of this is around 101 or 2 mm will be. Okay, 1 or 2 mm. Okay, so this is what the problem, and here it is an angle 40. Okay, welcome to engineering visualization channel. Okay, now we are discussing problems on points here. Okay, so it is one of the different type problem. It is a combination of 2 points A and B. Okay, so now we look at the question here. A point A is 30 mm in front of VP and 40 mm above HP. Okay, and it is and another point B is 20 mm behind VP and 35 mm below HP. The horizontal distance between the points measured parallel to XY line is 60 mm. Draw the three projections of the points. Okay, three projections of the points means here both top view, front view and side view. Okay, join their front views and top views. So we have to join both their top views and front views. Okay, so now first I am going to draw an XY line here. So this is X, this is Y. Now first we take the point number A. So point number A, what the information is 30 mm in front of VP and 40 mm above HP. Okay, 30 mm in front of VP and 40 mm above HP means it is the first quadrant. So 30 mm in front of VP means, so here I will be constructing 40 mm above HP means it is a front view. Okay, front view I am going to construct here. Front view we always got above the XY line here. Okay, so this is front view E dash. So you can show the dimensions also. It is 40 and 30 mm in front of VP. So in front of VP means it is the top view. So top view we getting below the XY line. So 30 means 3 boxes. Okay, and put a point. This is your A. Okay, this is 30. So top and front view of the point A is done. Now point B is 20 mm behind VP. Behind VP 35 mm below HP. Below HP means it is the third quadrant. Here behind of VP. So behind of VP means it is the top view. So here the top view we are getting above the XY line here. So here before that you can see here they have given one information here. The horizontal distance between the points measured parallel to XY line is 60. That means, so in order to before drawing the point number B, we should consider a horizontal distance of 60 mm here. Okay, here I'll mention with the dimension line. Okay, this is 60, and here we have to construct. So you can see 20 mm behind of VP. Behind of VP means it is the top view. So top view in the third quadrant we are getting above the XY line. So here, so this point is top view. So this is B. I'm showing the dimension line. This is 20. And same way 35 mm below HP. So below HP means it is a front view. So in the front view in the third quadrant we are getting below the XY line. So 35 means 3.5 boxes. See, this is 1, 2, 3. 3.5 means till here we have to extend. Use the scale or the box, no problem. You'll get the same length. Okay, this point is B dash. So this is done. So both top views and front views are done, and it is shown with a difference of at a horizontal distance of between the distance it is 60 mm. That is also done. Now, so the horizontal distance between the points measured parallel to x value is 60. Draw the three projections of the three projection means you can see this is front view, top and front view done. Now we have to draw the side view. Okay, side view we have to construct. So for this purpose, what I'll do, so we need to draw 45-degree angle line. First, for this point A, so the top view we are getting in the, so this is our top view, correct? This is top view and this is front view. So wherever we have the top view, on that side we have to draw the 45-degree angle line. Okay, so here I'll draw one x1 y1 line. This is x1 and y1. I'll use the protractor here, place it at the intersection of xy and x1 y1 and mark for 45-degree and then draw an angle line. Okay, now from this top view, so draw the projection line till it touches the 45-degree line and then project it upward. Okay, and then project has a projection line here also. Okay, so this is the point where we get the side view, A double dash. You can see always with respect to the front view we'll get the side view here. Okay, adjacent to it we'll get the side view. Okay, in the same way now we have to construct the side view of this point B. So you can see here the top view here, this is the top view. So top view here we're getting above the xy line, that means we should construct the angle line. So I'll take this as the reference only, x1 y1 line. I'll place the protractor here and mark for 45-degree angle and then draw an angle line here. Okay, and you can mention this angle here, it is 45-degree. Now project the line, that is projection line from this top view we have to draw, remember it, till it touches the 45-degree angle line and then project it downward till the B dash end. Okay, till here and then project it from here also. Okay, so this is our point, this is our side view, B double dash. Okay, this is our side view. So both the side views and side views of both point A and point B, it is done. Now join their front views and top views. So the front views, front view of A is here and front view of B is here. So I'm going to join their front views and top views with a straight line. I'm going to do that. Okay, and then joining their top views also. Okay, so this completes the problem. Okay, you can subscribe for the channel and hit on the bell icon for the latest notifications. Okay, and share it to the maximum students so that they can be benefited. Thank you all. Thank you for watching the video. Today we are going to learn about basic problems on projection of points. Okay, basic problems. Point A is lying at 30 mm above HP and 20 mm in front of VP. Draw the projections. So we have discussed there are three concepts in solving the projection of points. So first concept is to identify which quadrant. We know that if a point is lying 30 mm above HP and 20 mm in front of VP, that is above HP and in front of VP, it is an first quadrant. Okay, so now we have identified the quadrant. Now second concept is to write the notations in terms of xy line. Okay, you know that for first quadrant the notation it is VP will be above the xy line and HP will be below the xy line. So these two things are over. Now we are going for doing in sketchbook. Okay, so now you can see in this sketchbook each of these units, it is equal to 10 mm. Okay, the length, width, everything here, each box it is of dimension 10 mm, that is 1 centimeter. This is 1 centimeter, this is 1 centimeter. Okay, so first initially we are going to draw an XY line. Okay, that is the reference line. XY, VP, HP. Okay, this is an reference line. Okay, this is reference line. Okay, now we have to do the problem. Now we take one by one. Okay, a point A is lying at a distance of 30 mm above HP. We know that if any point is lying above HP, okay, if we know that if any point is lying above HP or below HP, means it is an front view. Okay, so the front view will be drawn in the vertical plane. So vertical plane, it is lying above the XY line. So initially we draw 30 mm. So 30 mm means 3 box here. So we can count the 3 box. Directly draw a projection line. Okay, we just draw to this line. Okay, projection line. So this projection line has to be thin. Okay, so we need to draw a thin projection line. Okay, drawing 30 mm, and you have to put a point. Okay, so this is an front view. Front view means it is A dash. It is A dash. Now we can show with the dimensions. This is 30. So similarly we have to write the top view. You can see that 20 mm in front of VP. We know that if any point is lying in front of VP or behind of VP. Okay, behind of VP or in front of VP means it is top view. So it is 20 mm. So 20 mm means exactly we can count the 2 box and draw a straight line, and we can put a point here. This is our top view. We can show the dimension line. Okay, this is 20. Okay, so now we have done with the first problem. Say we calling these two lines as projection lines. These are views. Okay, these are views. This is front view, this is also one view, this is top view. Okay, so now we have done with the first problem. Similarly, now we will write the second problem. Point B is lying at 20 mm above HP and 30 mm behind of VP. Draw the projections. Okay, here also we follow the same concept. First we will identify the quadrant. So here we know that if a point is lying above HP and behind of VP means it is an second quadrant. So we know that for the second quadrant, if it is written in terms of XY line, both vertical plane and horizontal plane lying above the XY line. Okay, now we draw the first we draw an XY line. So both VP and HP lying above the XY line. We know that if any point is lying above the HP means it is in front view. So first we draw in front view. If a point is lying above HP means it is front view. So we put a point here. This is B dash. Next 30 mm behind of VP. So behind of VP means it is also behind of VP means it is top view. We know that all these views are falling in a same collinear line. I'll be extending 10 mm. Okay, so it will become 30. This is top view. Now we will show the dimension line. So this is 20. Okay, and similarly this is 30. Okay, on the same collinear line, we calling this collinear line. On the same collinear line we get the views here. Okay, top view and front view. So this is we have done with the second problem also. Now we will move to the third problem. Point C is lying 30 mm below HP and 30 mm behind of VP. Draw the projections. Okay, so we need to identify the quadrant first. So below of HP and behind of VP. So that means this is an third quadrant. Okay, we have identified the quadrant. Now we have to write the convention for it in this third quadrant. So HP will be above the XY line and VP will be below the XY line. That it is nothing but reverse of the first quadrant. Okay, so now we represent in 2D. So initially we draw an XY line. So HP, VP. Now we have to draw the views. So 30 mm below HP. Below HP means it is, we know that in a concept that if a point is lying above HP or below HP means it is in front view. So front view will be drawn in the vertical plane. So in the vertical plane we have to draw 30. Draw a line and put a point. This is C. And show with the dimensions. Okay, now similarly we have done with the top view. Now we see similarly write 30 mm behind of VP. So behind of VP means it is top view, correct? Behind of VP means it is top. So again 30 mm line. So we know the top view will be drawn in the horizontal plane. Okay, so now we have done with the third problem. So similarly you can go for the fourth problem. Point D is lying 40 mm below of HP and 30 mm in front of VP. So draw the projections. Okay, now we have to identify which quadrant it is. So below of HP and in front of VP means it is in fourth quadrant. Okay, so point D is lying fourth quadrant. We know for the conventions both vertical plane and horizontal plane lying below the XY. Okay, and draw XY line here first. Both vertical plane and horizontal plane below HP. Now 40 mm below HP. So below HP or above HP means it is front view. So we draw the front view first. It means 4 boxes and you put a point. So this is D dash. Okay. So this is show with the dimension. Okay. Now 30 mm in front of VP. 30 mm in front of VP means it is top view. So we know that both the views are lying on the same collinear line. So this is our top view. Okay. So this is what we have done with the solutions of all the basic problems. Okay, today we are going to start the first problem in points. Okay, so we'll take the first problem. Draw the projections of the following points on the same XY line, keeping convenient distance between each projectors. Good. Name the quadrants in which they lie. So first one, point A, 30 mm above HP and 35 mm in front of VP. Point B, 35 mm above HP and 40 mm behind VP. Point C, 40 mm above HP and on VP. Next point D, 35 mm below HP and 30 mm in front of VP. Okay, so this is the problem. Say the basic problem which you have solved, it is only the one point on the XY line, but you see in this problem, draw the projections of the following points on the same XY line. That is, on the same XY line we need to project all these 4 points A, B, C, D on the same XY line. Okay, by keeping convenient distance between each projectors, and after that we have to name the quadrants in which they are lying. Okay, we need to mention either A is lying in first quadrant, B is lying in which quadrant, and C is lying in which quadrant, and D is lying in which quadrant. So that thing we have to do it. So first we are going to draw an XY line. Okay. First we are going to draw an XY line. Okay, herein you should not write VPHP. Okay, should not write, because there are 4 points are lying on the same XY line. Okay, so now we'll take one by one. First we will take point A. Okay, you can see the question. A point A is lying 30 mm above HP and 35 mm in front of VP. So above HP and in front of VP means it is an first quadrant. Okay, it is in first quadrant, right? So in first quadrant we know that. Okay, for your reference purpose I will be writing. So for first quadrant VP will be above X line and HP will be below the X. After drawing the projections we will erase this. Okay, so 30 mm above HP and 35 in front of VP, it is in first quadrant. So we know that 30 mm above HP, above HP means it is front view. So front view will be lying in the vertical plane. So we draw 30 mm means 3 boxes, and you put a point. So this is A dash. Similarly, so 35 mm in front of VP. 35 in front of VP means it is top view. So 35 means 3.5 box. Okay, 35 means 3.5. 1, 2, 3, 3.5. Okay, 3.5 box you have to mark. Okay, and you put a point here. That is your top view. Now you draw an dimension line for showing the dimensions. Okay, so this is 30 and this is 35. So now we have done with the point A. Similarly we look for the point B. So 35 mm above HP and 40 mm behind of VP. So above HP and behind of VP means it is in second quadrant. So point B is lying in the second quadrant. So after finishing this, you just have to rub it. Okay, remove this VP and HP. For reference, for your understanding purpose, you can write initially, then you can rub it. So 35 mm above HP and 40 mm behind of VP means it is second quadrant. We know that in second quadrant both vertical plane and horizontal plane are above the XY line. So 35 mm above HP means it is front view. So first we draw for 35, that is 3.5 box. Okay, and you put a point. Above HP means it is front view, B dash. Next 40 mm behind of VP, so it is in top view. Already we have drawn 35, so I will be extending by 5 mm, and you put a point. Okay, now we can write the dimension line. So this is 35, and here you can show it for the 40. So it is 40. Okay. Okay, now we have done with the 2 points. Now point C. So 40 mm above HP. okay, 40 mm above HP and on VP. So as we have discussed in the previous concept, so and on VP means it is our top view, okay, it is our top view. So above HP means, say here above HP, so we know this concept, so HP VP. So above HP means the point may be lying in first and second quadrant, okay, first and second quadrant. So the point may be lying in first and second quadrant. You can see that already we have completed the top view. Now above HP means it is front view. So now we have to look in for the front view. So front view in first and second quadrant. See, in all these cases you just see in the first quadrant, so where the front view is lying, okay, VP HP. So front view lying in the vertical plane, it is above HP. Similarly in second quadrant also you have to see for the front view. So front view here also it is lying above the X view. So in both these cases front view is lying above XY, okay. So front view is lying above XY. So first we draw a front view. So front view of, that is 40 mm above HP, it is in front view. So front view, it is lying in first and second quadrant. In both the cases first and second quadrant, the front view, it is lying in the vertical plane. So vertical plane, it is lying above the XY line, and similarly in the case of second quadrant also, vertical plane is lying above the XY line. In both the cases the front view will be projected on the vertical plane. That front view will be drawn above the XY line, okay. So that's why you will be drawing 40 mm line, 40 mm line, that is 4 boxes, and put a point. So that is front view, okay, front view okay, 40 mm. Now so we have this point on VP. So on VP means we know that it is in top view. So on VP means we need to project this point, that is top view, on the XY line. Please remember it. On VP means it is top view. This top view has to be drawn on the XY line. So okay, so here the point will be the point C, okay. Now similarly we will look it for the point D. So point D is lying 35 mm below HP and 30 mm in front of VP. So it is in fourth quadrant, correct? It is in fourth quadrant. So below HP, 35 mm below HP and 30 mm in front of VP, fourth quadrant. So we know that in fourth quadrant both vertical plane and horizontal plane are lying below the XY line. Now we see, so below HP, which it is in front view. So first we will draw in for front view. So that is 35, and you put a point, that is D dash, okay. Now similarly we have in front of VP. In front of VP means it is a top view. So here in both the cases it is projected below the XY line. I will put a point here, 30 mm. So it is top view D. Okay, now we are going to project it, draw with the projection line. Okay, so this is what, after drawing this, we will erase these things, okay, we'll erase these things. So this is we have written for our convenience, okay. Okay, now we have to write down. You can see in this question we have to name the quadrants, okay. We have to name the quadrants in which they are lying. Now we have to write for the first one, point A. So point A you can write here. A is lying. We know that it is lying in first quadrant. Okay, A is lying in first quadrant. Similarly for the B we will write B is lying in second quadrant. Okay, B is lying in second quadrant. Similarly C is lying, you can see that C is lying in first and second quadrant. Both the things you have to write. Okay, because front view it is lying in first and second quadrant, so we will consider front view as a reference for writing it. So here in the point C it is lying in first and second quadrant, lying in first and second quadrant. Similarly for the point D we will write, so point D is lying, so point D is lying, we know that it is lying in the fourth quadrant. Okay, it is lying in the fourth quadrant. Okay, today we are going to learn about basic concepts regarding projection of straight lines. Okay, in this first we are going to see the case 1. Okay, so with respect to these cases we are going to learn the basic things about the projection of lines. Okay, so first case 1, it is a line parallel to HP and VP. So in this the line will be parallel to both HP plane and VP plane. Say if I am considering, so this is your vertical plane and horizontal plane. Here our line will be parallel to both HP and parallel to both VP. So this is what the condition. Okay, case 1, it is parallel to HP and parallel to VP. This is vertical plane and this is a HP plane. It is parallel to HP and it is parallel to VP. So this is what our condition. So in this so we will deal with the problem. Draw two views of a straight line 60 mm long which is parallel to both HP and VP. Okay, so here you can see that the line it is parallel to both HP plane and VP plane. Okay, and then they have given the line is so the length of line we got to know it is 60 mm. Okay, so the length of line we have to draw, that is 60, and so it is parallel to both HP and VP plane. Okay, and here we have, so you can see that two views you have to draw, front and top view. Straight line 60 mm which is parallel to both HP and VP. The line is 20 mm above HP and 25 mm in front of VP. So here we are going to use only the first quadrant. So first I am going to draw an XY line here. Okay, so XY, VP, HP, first quadrant. Okay, so the line is 20 mm above HP. So above HP means it is our front view. So here vertically, so here I am marking 20. So this is 20 and 25 mm in front of VP. So in front of VP means it is our top view. So it is 25. So here we have to draw a line of length 60. Okay, so it is parallel means we have to draw a straight line. So from this end 6 boxes we can take, so up to 6 boxes here, and here also we have to draw for 6 boxes. Okay, so this is our line and we can show the dimensions. So this is our top view which is also 60 mm. Okay, so this is our front view. You can name it as B dash, B dash, and this is AB. So this is AB line of length parallel to both vertical plane and HP plane. Okay, we see second case in projection of lines. So the second condition is the line is parallel to VP and perpendicular to VP. So we have to make it parallel to HP and perpendicular to VP. So how to do that? Parallel to VP means here you can see this is our vertical plane, this is horizontal plane. In this condition we have to make it parallel. So you can see here this is parallel to HP. So this pen it is parallel to HP and it is perpendicular to VP. So perpendicular means you will get a dot here. Okay, you get a dot on the vertical plane, and there is a straight line in the HP plane. So this is what parallel to HP and perpendicular to VP. So like this we have to do. So first we are going to draw an XY line. Okay. XY, VP, HP, first quadrant we are using. Okay, so here the end of the line, so line it is, you see it here, line AB long parallel to HP we have to make and perpendicular to VP. The line is 20 mm from HP and 30 mm from VP. So 20 mm from HP means it is 20 mm from HP. So 20 mm above HP means it is in the front view. So here, so above HP means here, and 30 mm means here downward. Okay, here you can show the dimensions. So this is 30 and this is 20. So here from this end we have to draw an parallel line. Okay, see that this line 60, these 6 boxes. So it is A, B, line of length 60, okay, 60. And here we'll put a dot, that is A dash and B dash. Okay, so this point it is perpendicular and this is parallel. Okay, so this completes the second case. Okay, we see a third case. So third case is line parallel to VP and perpendicular to HP. So how to do this condition? We see it here. So this is our vertical plane and this is horizontal plane. So in this condition here, the line it is parallel to VP, straight line we get it in VP plane, and perpendicular to HP means we get a dot in the HP plane. This is what the condition, parallel to the VP and perpendicular to HP. So like this we have to do. Okay, line of length we have to draw a 50 mm. So here it is parallel to VP and perpendicular to HP. One end of the line it is 20 mm above HP and 20 mm in front of VP. So first we are going to draw an XY line here. VP, HP and Y. So here both the ends of lines are at a distance of 20. So 20. So we can show the dimensions on one side. Okay, from this end, so here we have to consider 6 boxes. This is A dash, B dash, and we can show the dimension here on one side. Okay, 60. And here we are going to put a dot. This is AB. Okay, so it is perpendicular to HP and parallel to VP. So this condition also so done. The fourth case, that is line inclined to VP and parallel to HP. Okay, so parallel to HP. So how it is here, you can see this is our VP plane, this is HP plane. So here you can see this is parallel to HP and parallel to VP. So here you can see that this is inclination, we are giving inclination. So whatever the inclinations here, so we will be giving like this. So it is what the inclination to VP. So this inclination to VP, so whatever we give, say this is what the inclination to VP and it is parallel to HP. Okay, so like this we have to do it. So here first I am going to draw an XY line. So VP, HP and Y. So 30 mm above HP and 20 mm. So here we can show the dimensions. Okay, so here it is. So this is 20 and this is 30. So whatever the inclinations we have given inclination to VP, that is we can show it in the VP plane. So sorry, in the HP plane. Inclination to VP, so we have to show it in the HP plane. So inclination to HP, say some 45 degree. We will give the angle 45 degree. Okay, here. So here I will take an angle of 45 degree and line of length. So line of length we have to take, that is 50 mm, and here the angle we can 45 degree. Okay, this is A, this is B. Now projecting upward, here we get the front view. So this is B dash, B dash. Okay, so this completes the problem. You can see. So this is true length of line. So it is 50. It's 50, right? So if the length of line, if this remains in after projection, say we calling that is true length of line. Okay, true length of line. If the length of line, if it is reduced, okay, after projection, we calling that as an apparent length of line. Okay, apparent length of line. Okay, so true length of line means the length of line will be remain same after projection. So that is true length of line. If the length of line it is get reduced after projection, we calling that as apparent length of line. Okay, so this completes the problem. See a fourth case in projection of line. So line is inclined to HP and parallel to VP. So here we have to give inclination to HP and make sure that line parallel to the VP. So how it is done? So you see it here. So this is vertical plane, this is horizontal plane. Say in this condition it is both parallel to HP and parallel to VP. So now what I'm going to give inclination like this. You can see here. So this is what the parallel to the VP, but here it is nothing but the inclination from the HP plane. Okay, it is inclined to the HP and parallel to the VP. Parallel to the VP means we get a straight line. So inclination to HP means either it is 30 degree, 45 degree, 90 degree. Okay, so this is what the inclination to HP and parallel to VP. So this is how we have to do. So for that, first I am going to draw XY line and first quadrant. VP, HP, Y. So you can see here the end of the line is 20 mm in front of VP, 30 mm above HP. So 30 mm above HP means here this is 30 and this is 20. So here the end of the line here you have to give the angle here first. It is inclined to HP. So whatever the inclination to HP it is there, it is seen in the front view. Okay, so it is seen in the front view. So here I am going to mark angle 60 degree. Okay, so here I am going to draw a line of length 60. mm line we have to draw. So 1, 2, 3, 4, 5, 6. Okay, 6. So it is having angle of 60 degree, and this is A dash, B dash, and this is the length of 60. So now projecting downward, so we'll get the length of the line here. So this is our top view, A, B. So here, this is what inclined to the HP, the inclinations to the HP, it is shown in the front view, that is in the vertical plane. Okay, so it is inclined to HP and parallel to VP. So this condition also done. Okay, we see some basic concepts in projection of lines. So as we are solving the problem, we should make sure. So we know that we have true length of line. We know that true length of line in top view, it is exactly equal to the true length of line in front view. Okay, so that is the first concept. And second concept is the true length is always greater than the apparent length. Okay, so we remember it. True lengths are always greater than the apparent length. And then apparent angles are always, which we find out, apparent angles are always greater than the true angles. Okay, this is the one of the difference. So when we are solving the problem, we should make sure the true lengths are always greater than the apparent lengths, and apparent angles are always greater than the true angles. In the true length in top view and true length in front view, it is always the same. Say true length is given if it is 80 mm in front view, and in the top view also true length is exactly 80 mm. Okay, so that's what. So the basic concepts in projection of lines. This case 6, it is the line is inclined to both HP and VP. So the line inclined to both HP and VP, it is nothing but the actual problems in projection of lines. Okay, so now we are dealing with the actual problem. So you can see here the line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Okay, so first I am going to draw an XY line here. So XY, VP, HP. So in this problem we have to draw the projections of the line and find apparent lengths and apparent inclinations. As we have discussed, apparent lengths are nothing but the reduced lengths. Okay, reduced lengths we have to find out. So first the end of the line, it is inclined end A, it is 20 mm above HP and 30 mm in front of VP. So 20 mm above HP, so this is 20 and 30 means here. Okay, so you can show the dimensions for it. So this is 20 and this is 30. The end of the line. So here the length of line, it is 80 mm. So AB, it is nothing but true length. You have to find out the apparent length. So angle of inclination they have given 30 degree to HP and 45 degree to VP. So first we are going to take the angles. So 30 degree inclinations. So 30 degree, mark at 30 degree and draw a line of length 80. So from this end, for this point, you have to mark till 80. 80 means 8 centimeter. Okay, so he is having an angle of 30 degree. Okay, now similarly you have to mark at 45 degree 45 degree to VP. Okay, a line of length again 80. Here we can show the angle. So this is 45 degree to VP. So you can show the lengths here. So this is having 80 mm. So this is 80 and this also 80. So these are nothing but the true lengths. So here we are going to give the naming for this. This is A dash, this is B1 dash, and this is A, and this is B2. And here after drawing this we have to draw the locus lines here. Okay, so drawing the locus line is very important. Okay, drawing the locus lines is very important. So locus lines we have drawn. Now we have to find out the upper end lengths. Okay, so how to find out the upper end lengths means here from this end, so we have to draw a straight line till this. So I'm going to mark this as a locus of A dash, and this is locus of B1 dash, and this is locus of A, and this is locus of B2. Okay, so from B1 dash we have to draw a straight line till the locus of A. So till the locus of A we have to draw. So you can show the RMR direction. Now after this we have to measure this length from here to here. Measuring this length we have to cut the arc. Okay, so this point I'm going to give this one as B1. Okay, so where the arc has been cut, we have to join from here to here. So this is AB. This is AB. The same way from B2 vertically upward till locus of A dash. So I will draw a straight line. So this is B2 dash. So by measuring from compass, measuring from compass from here B2 dash, so we have to cut the arc till the locus of B dash. Now we can join where the arc has been cut. This is A dash, B dash. Okay, so this is nothing but the upper end length. So this A dash, B dash. Okay, upper end length we are going to measure how much it is. Upper end length, it is measuring 57 mm. Okay, so okay, 57 mm upper end length. And this length we are going to measure. This is 67. Okay, 67. Okay, 67. And upper end angles, inclinations also we have to find out. So how much we are getting. So upper end length inclinations, here we have 45 degree. Okay, and this one we have, around 50-60 degree. Okay, so we are getting upper end lengths A dash, B dash 57 mm and AB 67 mm in the angles. Okay, 45 degree and 60 degree. Okay, so this completes the problem. This case 6, it is the line is inclined to both HP and VP. So the line inclined to both HP and VP, it is nothing but the actual problems in projection of planes. Okay, so now we are dealing with the actual problem. So you can see here the line AB 80 mm long has its end A, 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Okay, so first I'm going to draw an XY line here. So XY, VP, HP. So in this problem we have to draw the projections of the line and find apparent lengths and apparent inclinations. As we have discussed, apparent lengths are nothing but the reduced lengths. Okay, reduced lengths we have to find out. So first the end of the line, it is inclined end A, it is 20 mm above HP and 30 mm in front of PP. So 20 mm above HP, so this is 20 and 30 means here. Okay, so you can show the dimensions for it. So this is 20 and this is 30. The end of the line. So here the length of line, it is 80 mm. So AB, it is nothing but true length. You have to find out the apparent length. So angle of inclination, they have given 30 degree to HP and 45 degree to VP. So first we are going to take the angles. So 30 degree inclinations. So 30 degree, mark at 30 degree and draw a line of length 80. So from this end, for this point, you have to mark till 80. 80 means 8 centimeter. Okay, so he is having an angle of 30 degree. Okay, now similarly you have to mark at 45 degree to VP. Okay, line of length again 80. Here we can show the angle. So this is 45 degree to VP. So you can show the lengths here. So this is having 80 mm. So this is 80 and this also 80. So these are nothing but the true lengths. So here we are going to give the naming for this. This is A dash, this is B1 dash, and this is A, and this is B2. And here after drawing this, we have to draw the locus lines here. Okay, so drawing the locus line is very important. Okay, drawing the locus lines is very important. So locus lines we have drawn. Now we have to find out the apparent lengths. Okay, so how to find out the apparent lengths means here from this end, so we have to draw a straight line till this. So I'm going to mark this as a locus of A dash, and this is locus of B1 dash, and this is locus of B, and this is locus of B2. Okay, so from B1 dash we have to draw a straight line till the locus of A. So till the locus of A we have to draw. So you can show the RMR direction. Now after this we have to measure this length from here to here. Measuring this length, we have to cut the arc. Okay, so this point I'm going to give this one as B1. Okay, so where the arc has been cut, we have to join from here to here. So this is AB, this is AB. The same way from B2 vertically upward till locus of A dash. So I will draw a straight line. So this is P2 dash. So by measuring from compass, from here B2 dash, so we have to cut the arc till the locus of B dash. Now we can join where the arc has been cut it. This is B dash, B dash. Okay. So this is nothing but the apparent length. So this A dash, B dash. Okay, apparent length we are going to measure how much it is. Apparent length, it is measuring 57 mm. Okay. So okay, 57 mm apparent length. And this length we are going to measure. This is 67. Okay, 67. Okay, 67. And apparent angles, inclinations also we have to find out. So how much we are getting. So apparent length, inclinations, here we have 45 degree. Okay, and this one we have, around 50-60 degree. Okay, so we are getting apparent lengths A dash, B dash 57 mm and AB 67 mm in the angles. Okay, 45 degree and 60 degree. Okay, so this completes the problem. Okay, so we are going to solve second problem from the CAD solution book. Okay, in the projection of lines. Okay, in this problem, line AB 18 mm long is inclined at 30 degree to HP and inclined to VP at 45 degree. So draw the front and top views of the line and determine their length. So in this problem they have mentioned true length and the angle of inclination to HP and an angle of inclination to VP they have given. Now we have to find out the apparent lengths and apparent inclinations. Okay, so proceed with the problem. So first I am going to draw an extra line here. Okay, so any one of the reference point I will take here. This is A dash and A. Okay, here, so they have not given any end of the line distance, so no need to draw the locus. The locus line, it is there on the XY. So first inclination, it is inclination to HP at 30 degree, and here we have to draw a line of length AD passing through this point. So this is 30 degree. This is B1 dash. Similarly, we have to mark another angle at 45 degree, and this also having a length of 80. So this is B2. Now we are going to draw a locus line here. This is locus of B2 and this is locus of B1 dash. Okay, so now the procedure here it is, we have to project it downward till here. Okay. Now we have to take the compass measuring from here, so we have to cut the arc. This then we have to join So I'm going to draw this length, and this is our upper end length AB. Now I have to project it upward. So arrow mark I'm writing here. So we have to join here. So this is A dash, B dash. Okay, there are two upper end lengths we got. Now we have to measure the angle. Okay, upper end length angles. So here we have, so 45 degree. This is alpha 45 degree. And this is beta. We will give. So this is we are getting beta 55 degree, and this is 45. So we need to measure these lengths. This is around 57 mm. So we will write here A dash, B dash 57 mm, and AB. So alpha we are getting 45 degree. So beta we are getting 55 degree. AB length we have to measure. AB I am getting around 68 mm. So these are the things we have been find out. Okay, in projection of line. You can like the video, subscribe and share, and hit on the bell icon. Okay, we see another problem, that is problem number 3 from CAD solution book. Okay, so in this problem they have given line AB has its end 20 mm above HP and 30 mm in front of AP, and the other end 60 mm above HP and 45 mm in front of AP. Okay, and the distance between the projectors, end projector is given 70. So in this problem they have not mentioned either true lengths or any kind of inclinations. Okay, we have to use these end line distances so to do the problem. Okay, so now we are going to proceed with the problem here. First I am going to draw an XY line. Okay. So XY AP HP. So one end of the line is 20 mm above HP and 30 mm in front of AP. So 20 here and 30 here. Okay. So here we are going to show the dimension. So this is 20, this is 30. This is A dash and this is A. And then other end is 60 mm above HP. Okay, 60 mm above HP. So that is 6 boxes. Consider 60 here, 60. So what I will do 60 it is, and here it is 45. Okay. So this it is 45. Now I am going to draw the locus lines here. Okay. Okay, this is locus of B1 dash, this is locus of B2, and this is locus of B, and this is locus of A dash. Okay, now another thing what they have given in this question is distance between projectors. So distance between end projector is 70 mm. So I am going to draw that. So here distance between end projector is 70. So here I am going to draw on vertical line. Drawing it. So here I'm going to mention this is B dash and this is B. We know that as the apparent lines are drawn, so the endpoints, if you draw a straight line, so it will be falling in a straight line. Okay, so that's why we're getting this B dash and a B on a same line. So I'm going to join this. So this is apparent length 1 and this is apparent length AB. Okay, so these 2 points we're getting it. So now using these 2 points, we are going to draw, we're going to find out the, okay, so reverse here. So in this problem we have to do the reverse process to get the 2 lengths. Okay, so now we join from here. So this is B2. Okay, that is 1 true length. Now again from this end, so I can show the arrow mark direction in which these things are going. So now we will join this. Okay, so we'll find out the distances here. So true length we are getting around AP2 and A dash P1 dash, which is AP2 mm, and AB we are getting around 72 mm, and this is B1 dash, 81. So AB1 dash is 81 mm. So we have to find out the angle of inclination for the true lengths, okay, or apparent lengths. So here we are getting around 30 degree alpha. So alpha here we are getting it is 30 degree, and beta we have to find out. So beta we are getting around 20 degree. Okay. So this problem it is done. We solve another problem from CAD solution book, that is problem number 5. Okay, so what is given in the question? The top weave PQ of a straight line, the top weave PQ of a straight line is 70 mm. So they have given the top weave of 70 here and makes an angle of 60 degree with XY. The end Q is 10 mm in 10 end Q is 10 in front of VP and 30 mm above HP. The difference between the distance of P and Q above the HP is 45. So draw the projections and determine its true length and true inclinations with HP. First we are going to draw the end points. So for that first I am drawing an extra line here. Okay. So VP HP, Y. So end Q distance given. So end Q it is 10 mm in front of VP. So from here it is Q and 30 mm above HP. So here it is Q dash. So we will show the dimensions. This is 30. And this is 10. And here another thing, the difference between the distance of P and Q above the HP is 45. So the distance between this P and Q, we have to consider the distance of 45 here. From this here I'm going to consider 45 here, sorry, till here it is 10, 20, 30, so 45. Okay, so here I'm going to draw on locus, and here also I'm going to construct a locus line here. Okay, and here also the locus line. Okay, now so with the question they have mentioned, so the top of VPQ of a straight line 70 mm, so 70 mm, so with the angle of 60. So here, keeping at this point, so marking at 60 degree, I'm going to draw 60 mm line here. So this is having inclination 60 degree and this is P. So here I am going to draw a locus line, another locus line here. Okay, so now to find out the true length, this is one of the apparent length, right? So apparent length will always be rotated, you remember it. So apparent length, it is going to rotate it like this, and then projected upward, so to get the true length. This is true length, so this is, so you can say P1 dash. Now so we are getting one apparent length and one true length. Okay, so now we have to get another apparent length. How to do? We know that apparent lengths, when they have been projected, so they are falling in a straight line. So I'm just drawing a straight line here. So this point we having, this is P dash. So now we are getting another apparent length in front view. Okay. Apparent length in front view. Now we are going to rotate this apparent length. So in this direction, then projecting downward, so this is, we have another true length. So we are going to measure the true length. So true length we are getting around 76 here. Okay, so you can write here, so you can like write it Q dash P1 dash is equal to Q P2. So you can measure here, it is around 75 mm we are getting. Okay, and true angle of inclinations we have to find out. So the first angle we are getting, it is around 37 degree I'm getting. This is side 37 degree. Okay. And second angle I'm getting around, so this is theta and this is psi. So psi I am getting around 45. So this completes the problem. So remember it. So always apparent lengths are going to be rotated. Okay, so I'm going to make this apparent length darks. Okay, so apparent lengths are always rotated, so true lengths are never be rotated. Okay, so remember it, this is one of the important point. So apparent lengths are rotated using compass. Okay. So we never rotate true lengths. So this is one of the important note, you can say that Okay, apparent lens are always rotated when we are doing the problem. Two lens were never rotated using compass. Okay, so that is the important thing. Another problem from CAD solution book. It is problem number 6. Okay, so in this they have given line PQ, true length 85 mm long, as a end P 10 mm above HP and 15 mm in front of VP. In the top weave and front weave of line PQ are 75 and 85. So these are the apparent lengths they have given. So this is true length 85. These are apparent lengths. So using these things we have to solve the problem. So we have to find out the true and apparent inclinations in this. Okay. So first I am going to draw an XY line here. So XY, VP, HP and Y. So the endpoints first I am write 10 mm above HP. So 10 mm above HP and 15 mm in front of VP. So here I am going to draw a locus line. So wherever the endpoints were there, we have to draw an locus lines. Okay. So this point is P dash and this is P, and it is having a dimension of 15 and this is 10. Okay. And the top view and front view of line are 75 and 80. So the top view here, so this here on the HP plane we get getting top view, so it is of 75. I'm going to measure 75 from the scale. Okay, 75 from the scale I'm going to measure, and here I'm going to cut the arc. Okay. And then I'm going to extend this. Okay. Extend it with a straight line. Now I'm going to measure 85 from the compass and using scale. You can measure and you can cut the arc. Okay. So then join. This is having 85 mm and true length it is 85, and this is Q1 dash. So here on locus line here. Okay. So now we are getting the true length 85 here and the locus line. So next thing we have to do is again we have to consider this. The front view we have 80. Take here from the scale 80. So from this end I'm going to draw a vertical line here downward. Then again I'm going to measure 85 from the scale using compass. Okay. So now I'm going to cut the arc here. So here is another true length. Okay. This PQ2 is also 5 mm. So here we get another locus line. Okay. So now using this 75 mm here, we're going to cut the arc exactly here. Here we're getting the apparent length PQ, and here upper end means PQ dash. Okay. Now we have to find out the angles. Okay. Find out the angles. So first I'm going to find out the theta. So theta I'm getting around so much theta, it is around 28 degree. Okay, psi we have to find out. Alpha also, alpha I'm going to find out. So alpha I'm getting around so alpha I'm getting around 28. Alpha I'm getting around 28 degree here. Now psi we have to find out. Psi we have 20 degree, and beta I'm getting around 23 degree. Okay, so this completes the problem. Okay. We do another problem from CAD solution book. It is problem number 7. Okay, so what is given? A line has its end 10 mm above HP, 15 mm in front of VP, and end B is 15 mm above HP. The line is inclined at 30 degree to HP and 35 degree to VP, and the distance between the end projectors given is 50 mm. So now we have to use we have to go step by step here. So first I'm going to draw an XY line here. XY VP HP, same points, 10 mm above HP means this, and 15 mm in front of VP. And here we have locus line, and here also we have locus line. Okay, so this is A dash and this is A, and it is having a dimension of, so this is 10 and this is 15. Okay, now another end we have, that is 55 mm from here, that is, so 55 is still here. Okay, here another locus. Now so we have to use inclination. The line is inclined at 30 degrees. So this is nothing but inclination to the true length. Okay, so from here we are going to mark for 30 degree. Then we are going to draw a straight line passing through a point. Okay, so this is 30 degree and this is B1 dash true length. Okay, and another one is 35 degree to VP. I'm marking at 35 degree and draw a line. We have to find out how much length. So because we know that true lengths are same in both top view and front view, so we have to use this. So here we have true length, I'm getting around 88 mm. So this is the true length. So here also we have to draw another this is 35 degree. Okay. CS 90, CB 30. CB lo EC CS ಎಲ್ಲ ಸೇರಿ 110 ಜನ. EC ನೋ ಅಷ್ಟು ತಗೊಳ್ಳಿಲ್ಲ ಅನ್ಸುತ್ತೆ. ಯಾ ಸರ್ ಈಗ ಎರಡು ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ಎರಡು ಪ್ಯಾಟರ್ನ್ ಇರುತ್ತೆ. ಎರಡು ಸೆಕ್ಷನ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲ CS ಎರಡು ಸೆಕ್ಷನ್ ಮಾಡಿ CB ಒಂದು ಸೆಕ್ಷನ್ ಮಾಡಿದ್ರೆ 100 ರೂಪಾಯಿ ಇರಬೇಕಾಗುತ್ತೆ. CB ಅಂದ್ರೆ ಯಾವ ಸೆಕ್ಷನ್ ಸರ್ 6 ಅವರು ಅಲ್ಲಿ 45 ಮಾಡಿಬಿಟ್ಟು ಎರಡು ಸೆಕ್ಷನ್ ಮಾಡಿ CB ಅಲ್ಲಿ ಸೆಪರೇಟ್ ಮಾಡೋದಂತೆ 30 ರೂಪಾಯಿ. ಮೇಬಿ ನೀವು ಬರೋದು ಯಾಕೆ ಇಲ್ಲ So now we have to find out the angle here. So apparent angles we have to find out. Alpha, I'm getting around alpha 32 degree, and here beta I'm getting around 44 degree. Okay. And true length we have a dash, b1 dash, and a b2, it is around 88 mm. So that completes the problem. Okay, we solved the problem number 9 from CAD solution book. So it is, you can see in this problem they have given line of AB 60 mm as one of its extremities. Extremities means end point. Okay, so 20 mm in front of VP, 15 mm above HP. The line is inclined at 25 degree to HP and 40 degree to VP. So now we'll proceed with the solution here. So first I'm going to draw an XY line here. Okay. X, VP, HP, and Y. So end point here 15 mm above HP, 15 mm, and it is, and 20 mm in front of VP, 20 mm in front of VP here. So here we are going to draw an locus line. And this is 15. And this is 20. Okay, 15 and 20, and this is A dash, and this is A, and we have angle of inclination here. So 25 degree to 25 degree to HP. Okay, and 40 degree to VP. So 40 degree to VP. Here the length of line we have to draw, that is 60. Okay, here to these extremities again another locus line. So this is the AB2, another length of line 60 we have to draw this end. Here another locus line. Okay, so this is B1 dash, and show the dimension here 60. We can show the dimension. This angle it is 25 degree, this angle it is 40 degree. Okay, so now this is true length. Now we have to find out the apparent length. So apparent length, it is going vertically downward till the locus of A. Now we have to take the compass and we have to rotate it till here. So here at this point we are getting apparent length AB. So we have to dark this apparent length. Okay. Now from this side this is what I want to tell. So if you just draw a straight line connecting the apparent length top face and the bottom face. Okay, so this front view and top view, it is drawn, you'll get the straight line. Okay, that is what. So you can see A dash and A dash, A it is in the collinear line, and B dash and B in the collinear line. Okay, so this completes the problem. Okay, now we can find out the apparent length angle inclinations here. So So apparent angle we have, so first angle we have here is around alpha is 34 degree, and this we have it is around beta. So beta angle we are getting around 46 degree. Okay, and then apparent length we have to find out. Apparent length, this is AB we have 55 mm, and B dash we have 46 mm. Dash B dash 46 mm. Okay. So this completes the problem. You solve problem number 10 from CAD solution book. So in this line AB measuring 70 mm has its end 15 mm in front of EP, 20 mm above HP, and the other end B is 60 mm in front of EP and 50 mm above HP. So first I'm going to draw an XY line. EP, HP and Y. So 20 mm above HP means here 20 and 15 mm means here. So here we are going to draw an locus line. Above HP, it's 50 and 60 mm in front of EP. So here also we can draw an locus line. So this point it is A dash and this is A. So we have a line of 70 mm. So we have to measure 70 mm from 70 mm 7 cm from the scale. Okay. So and we have to cut the arcs from this end to here, first arc, and the second arc from this here to here. Okay. So now we have to join. So these are nothing but two lengths. Okay. A, B, 2, and here from this end to here, this is B1 dash. This is having exactly 70 mm. And this also 70. So now, projecting upward this line here, and from here we have to rotate this apparent length till here. Okay. This is B dash. Similarly, so you can project it downward till here, and measuring from here we can cut the arc and can join this. This is AB. So now we can measure the length here. So A dash and B dash, it is around 55. So sorry, not 55, it is around A dash, B dash. So we have to find out here inclinations. Okay, not the length here. You can see here, find the inclinations. We have to find out the inclinations here. So inclinations, what we are getting, both the inclinations we are getting. First angle we are getting around, it is theta, 25 degree here. this is 25, it is theta, and alpha we are getting, this is 34. Now here psi we have to find out. Psi we are getting around 45 degree. This is psi. Okay. This angle getting around, it is theta we are getting 55 degree. So sorry, psi we are having 40 degree. And this beta we are having, it is 35. So you can mention the angle here: theta 25, alpha 34, psi 40 degree, and beta 45 degree. Okay, so this completes the problem. Okay, so when you are doing it, so always make sure you have to dark this upper end length. Okay, you have to dark the upper end length. The upper end length has to be more thick compared to your true length. Okay. Today we are going to learn about midpoint problem in lines. So it is problem number 37 from CAD solution book. So you can see in this problem, draw the projections of a line AB 90 mm long. So here they have given true length of line, okay, and find its true and upper end inclinations. We have to find out, that is theta, psi, alpha, beta, everything. So with HP and VP, when end A is on HP and 20 mm in front of VP. So for the end A they have given the distances, and for the midpoint M, it is 20 mm above HP and 40 mm in front of VP. So now first we are going to draw XY line, and then for the end points we are going to draw. Okay. So X, VP, HP. So end A here, you can see that end A is on HP and 20 mm in front of VP. So 20 mm in front of VP. So here we are going to draw an locus line. Okay. So this distance, it is 20. Okay, for the midpoint we have 20 mm above HP, 20 mm above HP here, and 40 mm in front of VP. Okay. So here also we are going to draw an locus line. Okay, so I'm going to mark a middle point here. This is M dash, and here we have M. Okay, so middle point it is drawn. So now we have true length of line, it is 90. So half means it is 45. So we have to consider. So 45 length I have considered. And here from this point on the XY, I'm cutting first arc. Okay. So now we have to join. So we can extend it. Another 45 length. So extend it. So this is B dash and this is B1 dash. Now here we are going to draw another locus line. Okay. And this is having the length of 90. So it is having a length of 90 mm. Now same way, so we already measured 45. So from this end here we are putting the arc. So this is E. So we are going to extend this
till here. So this is B2. Okay. So another locus line is drawn, and this is having the length of 90. So now we have to find out the upper length. So we have to project it from B1 dash till the middle point of M. So where the locus of L is there, till here we have to extend. So from this end to here, measuring this length, so we have to cut the arc. So now we can find it. So this is B. Okay. So we have to extend from here till the locus of M. Okay, so till the locus of M we have to extend. So measuring from this length, we have to cut the arc. Can show the another direction here. So we are extending it. So this is A. Now in the same way, so we are going to extend from this A till the middle point of M here. Okay. Now measuring this length to here, so we have to cut the arc till the locus of E. So we have to join it here. Again from extending from this point to the locus of M. Okay, measuring this length, we have to cut the arc. So this is the direction in which it is cut. Now from here to here, we have to join. Okay. So this is V dash. Now we have to find out the angles. So you can see that we have to find out the angles here. So true length angle, that is theta, we are having 25 degree, and alpha we have around 29 degree. Same way here. Psi we have 26 degree, and beta we have around 31 degree. Okay, so this completes the problem. So you can like the video, share it, and subscribe for the channel, and hit on the bell icon. It is one of the special type of problems in lines. It is problem number 39 from CAD solution book. So you can see in this problem there are two lines given, two lines AB and AC makes an angle of 120 degree between them in their front and top view. Okay, AB and AC, so that will be making an angle of 120 degree, and AB is parallel to both HP and VP. Okay, so we have to make AB, so both parallel to HP and VP. Determine the real angle between AB and AC. So how we do that? So first we have to draw an line here, XY line. So I will take here only. So XY line, XY, VP, HP. So first I will draw a line AB. So you can see that AB line parallel to both HP and PB. So I will take around 6 mm length line. So this is A dash, this is B dash. Okay, the same manner here, parallel to it, because the AB line, it is parallel. Here I am considering 60 mm. Okay, so this is B. So AB line, you can see that line AB, it is parallel to both HP and VP. It is parallel to both HP and VP. Now AB and AC makes an angle of 120 degree. So here I take so marking at 120 degree here, and then marking it here also 120 degree. Okay, so we have been marked 120 degree. Now I'm going to join this line. Okay, so line of length will take around here will take around here 50. Okay, so 50 will take here, this BC length 50. Okay, so this is C dash, and here BC also. So 50 will take, okay. So BC. So here we have angle 120, and this is also we have 120 degree. So this is done. Now so we are going to join it from this end to here, we join, and here also. So we have to join. Okay, here I will draw locus lines. Here also we have to draw the locus lines. Okay, here also we have to draw the locus lines. Okay, so now after this what we have to do is, so we have to measure the length from here B to C, measuring this length. Okay, so we have to cut the arc. So this is, we have this is C1, and now measure this length. So this length is C2. Now so this is will give C2. Now projecting upward till here. Okay, so till here I have to project it. So now we are going to join this. So at this point we have C1 dash, and this point we have C2 dash. Now after this what I have to do is, we have to measure the length from here to here. So I have to cut one arc, and after that measuring from here, so you have to cut this arc. So here, so this point we have, this is C2 dash. Okay, this point. So this point we have to join here. This point we have to join, and now from here to here I'll join. Okay, now this angle we have to find out. Okay, so this angle till here. So the real angle between the lines here we have. So we're getting here real angle. So real angle we are getting around, you can see here it is 120 12 degree. So 112 degree is the real angle. Today we are going to do midpoint problem in projection of line. Okay, so this is one of the important problem. Here in this problem, a straight line given AB measuring 80 mm long has the end A is in the HP and 25 mm in front of VP, and the midpoint M is 25 mm above HP and 40 mm in front of VP. So this is our problem. So first we are going to draw an XY line. Draw here. VP, HP and right. So here in this the end A is in HP and 25 mm in front of VP. So 25 means here. So here we'll draw a locus line. Okay. And one end it is in HP. So here we get. So now for the midpoint, so it is one end of the line is in 25 mm, so 25 it is done. Now here for the midpoint it is midpoint M 25 mm above HP. Okay, 25 mm above HP. It's 25, and this also. Here we draw an locus line here. Okay, locus line here will be drawn. Another is 40 mm. So this is 40. Okay. So here also we draw an locus line. Okay, so after this we know the straight line AB measuring 80 mm, so it is measuring 80 mm. So that means, so we have to take a compass and measure 40 here. So measure exactly 40 mm. Here from this end, any one end you can choose. Say I will choose this is our midpoint M. If I choose this is M. Okay. Here choose this is M dash. Okay, from this point, so we already measured 40 mm because it is 80, so I am taking half part means it is 40. So we are taking 40 mm here. Going to cut it. So after cutting the arc, I'm going to join it. Okay. So in a straight line, I'm going to extend this till 8. Okay, till 8 I have extended. So this point we have B dash and this is B1 dash, and here also we get the locus line. Okay, same way here also we do. So the point already we have measured 40, so I'm going to cut the arc. Here I'm going to join. Okay. I'm going to extend it. Okay, here at this point to draw another locus line. So this point it is, so this point, sorry, so this point it is A and this point is B2. Okay, this is A, this is A dash and this is B1 dash. Okay, so it is done. So now you can see that this is our true length of line. Okay, so these are true length of line measuring 80 mm. So now we have to find out the upper end length. Okay, so how to draw upper end length means here we have to project it downward till here. Okay, till the locus of M. So we have to project it downward by taking this length. Okay, measuring this length here, measuring this length, we have to cut the arc. Okay. So till here. Okay, this is one point, this is B. Now in the same way, so we have to extend from this end till here. Okay, till here. Now measuring from M to here. So I have to cut back. So this point it is B. So now we can join these two lines. So this we have the upper end length. Sorry, this is not B, this is A. So we have AB upper end length, we got it. In the same way, so we find out the upper end length. So we draw a straight line till the locus of M here. Okay, till the locus of M. So from this point to here, measuring this length, we are cutting the arc. Join, and this is B dash, again extending from this end, measuring this length from here to here. So I'm showing the direction of the arrow mark, in which direction we're taking it. Now we have to join so this is A dash, this is A dash and this is B dash. So this completes the problem. You can see that we have to dark this upper end length. AB, this is A dash, B dash. Okay, so this completes the problem. Problem number 25 from projection of line. So in this straight line PQ inclined at 40 degree to VP has PQ 60 mm and P dash Q dash 60 mm. So this is upper end length and this also upper end length. So end P is both in HP and VP and 40 mm from the right or the left profile plane. Okay, so draw the projection of straight line PQ, find the true length and true inclination with HP. Draw the profile weave of the straight line and find the position of the end Q with HP. In this problem, you have to find out the side weave also. Okay, side weave. So first I'm going to draw a straight XY line here. VP, HP, and here right. Okay, so first, so we know the end point P is both in HP and VP, so that means it is P dash and it is P, and here P dash Q dash 40 degree to VP has a PQ 60 mm. Okay, so PQ having 60 mm, so it is at 40 degree. So line of length we have to take here 60 means 6 mm. Okay, so PQ is 50 degree. So this is 60. Okay, so now so that is 40 degree to VP, that's why we have drawn a line here. Okay, so now so we know that we will drawing straight line here. We know that PQ it is 60 and P dash Q dash 50. So that means I will take, we know that upper end lengths will be falling in a straight line. So now I am measuring 50 mm from scale. So measuring 50 from scale, I am cutting the arc here. This is P dash Q dash, and here we have focus line. Okay, now I'm going to take this length and we are tilting now to find out the true lengths. Okay, so this Q2. So taking this length, so we can cut this Q1 dash. We can rotate this also to get that. So it is done. This is 50. Now we'll find out now here. So from this end, so we'll be drawing a line of 40. You can see this here, 40 mm from the right of the left profile plane. So right of the left profile plane here, we're going to draw another line for, so this is x1 and y1, and here and for the top view I'm going to draw 45 degree angle line. And here from this dash there is a line going in this direction. Okay. Paramount direction. So So this here we have Q double dash, and this point we have P double dash, and this is our side view. Okay, our side view, and this is the dimension we have to measure. So it is M, it is 22. Okay, so in this length also we have to measure. So this is having 38. So this value is here 38. Okay, so now true length we are going to measure. True length of around 63. True length in front view is equal to true length in output, that is 63. Angles we have to find out. Theta 20 degree, alpha 25 degree, plus psi we have 38 degree, so beta 50 degree. Okay, so this is the length we have. Next we have M around 22, then we have 38. Okay, so this completes the problem.